Okay, this is an example problem for Snell's law, which you're going to have to be able to do on your test. So this will also help you with some of the homework questions. It says flint glass has indices of refraction for red light of 1.57 and for violet light of 1.59. If light is incident in air at an angle of 65.0 degrees, what will be the angle of refraction for red light? So, first thing you need to know is the equation for Snell's law. It says Ni times the sine of theta I equals Nr times the sine of theta r. And what this means is the index of refraction of your incident material times the sine of the angle of incidence is equal to the index of refraction of your refracted material times the sine of your angle of refraction. So, it tells us that it's incident in air. So, our index of refraction for air is 1. That's just something that we know. Index of refraction for air and a vacuum are 1. Air, it's actually 1.0003, but we're going to round it to 1 because it's close enough. The angle of incidence, it tells us, is 65 degrees. So, 65 degrees is our theta I. Our index of refraction, it says the index of refraction for red light is 1.57. And it wants to know the angle of refraction. So, we're going to take our equation, Ni times the sine of theta I equals Nr times the sine of theta r. Now, for those of you who are not real familiar with trig functions, don't really worry too much about the sine right now. Just consider the sine as just a button on your calculator for the moment. Right now we're trying to find theta r, so we need to move the things that are not theta r over here. So I'm going to move my Nr to this side. It's being multiplied, so I'm going to divide it Nr. So I divide both sides by Nr. Okay? So that gives me Ni times the sine of theta I divided by Nr equals the sine of theta r. Okay, I'm going to go ahead and put this in my calculator. The first thing you need to do before you do any of this is double check by hitting mode and double check to make sure that your calculator is in degrees. If it says radians, you're going to get the wrong answer on this. We don't use radians for this stuff in physics. So make sure it's in degrees. When you're using it in this class, it should already be in degrees, but so make sure it's in degrees first. So we're going to go ahead and put our numbers here. We've got Ni is 1.00, because that was our index of refraction of air, times the sine of 65 divided by Nr, which was 1.57. And that equals the sine of theta r. So let's go ahead and put that in our calculator. We're going to do 1.00 times the sine, so just push the sine button, of 65, and make sure you close your parentheses. I'll go ahead and multiply that out, and then divided by 1.57. Okay, so that gives me 0.57726611064. You don't necessarily have to write all that out, and that equals the sine of theta r. Now I want to get rid of the sine, so I'm going to do the opposite of the sine, which is the opposite of the sine is sine to the negative 1. So in my calculator I have this answer. I'm going to do second sine, so it says sine to the minus 1, and then I'm going to do second, and then this button here for the answer. So I'm going to take the inverse sine of this number. Boom. So my theta r is 35.3 degrees. And there you go. That's how you would solve a Snell's law problem. This is Snell's law right there. Woohoo.